down 4th, or was that on 42?
I was at the water tower on Richburg Road.
Okay.
So I was slowing down.
Where the fight was. The water tower.
Yeah, exactly. Where the fight. All right. All right, so we've now calculated all of these things. The perimeter area ratio, which we call in this document, oops. In this document, we call it the para. So we calculated para, calculated the shape index, we calculated the S circle, okay? The only thing that we haven't calculated yet is this related circumscribing circle. And this one's gonna be a little more involved, I guess is what I should say. So what this is going to do is it's going to take the smallest circumscribing circle and just calculate the ratio of the area of that circle to the circle, I mean, to the regular area. Okay, so it's always going to be larger unless it's a circle. If it's a circle, the minimum bounding circle will be the same thing, right? That makes sense? So if the city is already shaped like a circle, the minimum bounding circle will be that circle. If the circle is any larger, sorry, if the shape is not a circle, it will be a little bit bigger than that circle. Does that make sense? All right, so we need to figure out how to get this code that I have, and I put it in sec.py. Okay, smallest enclosing circle is what this guy created. So he said this is free software, you can redistribute it, which is good because I'm using it. Okay, all right, so this is the code that we want to use. And this is the function that he's written that will make the minimum enclosing, so the smallest enclosing circle. So this function returns the smallest enclosing circle. We have to read his little documentation to see what it wants and what it's going to get back. So what does it want? It wants points. Okay. What does it get back? It gets back a C. So let's see what it says here. All right. So a point is a pair of floats, and a circle is a tuple of floats. So it's going to return a tuple of floats where we get an X and a Y, which represent what do you suppose? The center and the radius. So that's going to be the result. Okay. All right. What do we give it? A sequence of pairs of floats or ints, for example. So basically, we want to just give it a bunch of XYs, the points. So we have to get the points first. Now, if you remember last week, we actually did, remember when we ran that code and it just looked like blue numbers were just like going everywhere? And I was telling you, those are the individual points. That's what we need. We need to actually feed it all those individual points. That makes sense? That's what we need to feed it. So we need to feed all those individual points. And what we're going to get is the center point of the circle and the radius. Okay? Now, strictly speaking, all we need at that point is the radius, right? Because we don't really care what the center point is if we're just calculating this metric. But we're going to use that for fun. just to show you what we're actually creating. Okay, so let's look at what we need to do here. So somewhere, let's put this before we do the print statement so we can print everything, because we want to also print this, what did I call it? We want circle. I don't want to call it circle, so I'll call it, I'll just call it C circle. So now I have printed all 4 of those metrics, 1, 2, 3, 4. But we need to calculate C circle. I'm going to put this code in here. Calculate C circle. Okay? That's what we need to do. Now, I said that we need to get all of the points from the geometry. Okay. Do you remember how we did that, or how we did that last week? We used a loop, right? So the first thing that we have to do is say for part, well, we doesn't have, that's a variable name. I like to call it part because part is what it is. It's a part of a polygon, because some cities are discontiguous. Didn't we find a discontiguous city in Mississippi? Yeah. So some cities are discontiguous, and some cities may have, I don't know if this happened in Mississippi, but some cities in the world may have a donut. In other words, an area that's not incorporated inside of them. Oh, okay.
It's a 6 part, but it's not in the city.
Not technically in the city. So
Campuses, college campuses typically
are their own city? Okay.
typically.
All right. But in any case, if there's any of those 2 cases, you're going to have multiple parts to your polygon. So we'll say 4 part in, and then what's the name, so far right now, what's the name of our shape? Did we give it a name yet? How do we access the shape? Where? Oh, okay, yeah. Well, you're right. Well, this is where we first kind of point to it, but it's one of these row variables. Is it row 0 or row 1? Right. Now, when we say row 1, we're not talking about, we're looping through each row. So at each row, we've got 0 and 1, and it's 1. So we say row 1 like that. And what we're saying there is that for each part in that row, do something. Okay. I'm going to print part right here, but before I do that, I only want to do this once because I don't want to have a loop a ton of times. I forgot. Break. Okay. So we did learn about that. I'm going to put a break statement right here. So it's actually only going to run this code once. Now I'm going to delete the row so we don't leave that open. I'm also going to break. Yeah, no, that's fine. All right. So you see what I'm doing here is that I'm going to print the entire part, and eventually I'm going to print all the points. And I don't want to do that for every single city and every single state because it would take too long to run all that code. So I'm only going to do this for the very first one. Does that make sense? All right, so now I'm going to run this guy and see what the results are. So I don't know what the very first one is in our list. Okay, well, it looks like I'm also going to have to comment out this I'll just take this out for now, but that's what we're working toward. Run this one more time. All right, so now it's going to run without a. So right now it's not that big of a deal because it's just printing out telling us that it's an array object. Okay. So in order to get the pieces of the part, I have to say, how do I loop through those? We did last week, we did chord. Coordinate spelled with 2 O's? Chord in part. Print chord. So now I'm going to print all of the coordinates in each part. Now, if I'm trying to come up with the minimum bounding circle, does it matter if there are 2 polygons or if there's a part within a part? Not really, right? I'm just trying to come up with the smallest circle that fits around it. Doesn't really matter if it's a weird shape. All right, you see all this, these guys? These are the coordinates. Okay? We're going to take these coordinates and we have to feed them into this function. But it doesn't just take the coordinates like this. So we have to create our own list and then feed in the coordinates. And how do we create a list? Let's create a list right up here. So we'll just call this point list. How do we make a list? Equals what? How do we make a new empty list? Good. All right, so a point list. All right, instead of printing the coordinates, what I want to do is add them to my point list. Point list dot append, and I want to append a tuple. So I'm going to say, okay, append chord 0 and chord 1. So what it's doing there is saying, okay, I'm going to create a tuple. I'm going to feed in coordinate 0 and coordinate 1 as the 2 items in the tuple. So I'm creating a tuple for each coordinate, and I'm giving each of those tuples, I'm putting them into the list. So I'm going to print the point list here. Oh, it's not 0. It's we say like get X or something. I forgot. I think maybe it's just dot X and dot Y. I forgot what it was last week. See if that works. All right, that worked. Okay, so it wasn't chord bracket 1 and chord bracket 2. It was dot X and dot Y. So a coordinate is actually an object, not a tuple. But I need it as a tuple, so I'm creating the tuple right here. How do you know that I'm creating a tuple here, by the way? Right here.
2 items.
The parentheses give it away. Okay. So there's a lot of coordinates in here, but you can see this bracket down here means it's a list, and then there's a bunch of tuples. So sorry, I should stay over here. This bracket means it's a list, and then it's filled with these tuples. There's one tuple, there's another tuple, there's another tuple, there's another tuple, and so on. So this is just what we need to have it run. Okay. All right, so does everybody's run?
Yes.
Good.
So these are coordinates for.
They're the coordinates for the first city. Let's see what city. It's Port Gibson. These are all the coordinates for Port Gibson that form the boundary of Port Gibson. Where is Port Gibson anyway? Okay. Yeah, these are just Mississippi cities. Okay, so
Near the border.
yep, near the border. Yeah, that's you were saying near the border south of Vicksburg, so near the Louisiana border. Okay, all right. So now we have everything ready to go. We have we have all the coordinates that we need that are going to go into this sec.py. All right. Okay. So what we need to do, there's a few things we need to do. First of all, I've been using the file you sent. I'm going to resave this as the file that I was working on so that it'll go on back up on GitHub. So this is going to be 2016 example. I'm going to call it 2016 example 2. Well, actually, we're already, well, I haven't been saving as many examples along the way, but I'll still call this 2016 example 2. All right. Okay. So there it is. All right. It works. Now what we need to do is you need to take this file, sec.py, okay? You can go into GitHub and copy the whole thing, but you need to make sure, yeah, you need the whole thing. You need to make sure you get the whole thing, okay? Right click, copy, and then go to open up a new window, a new file in Python, and paste the contents in there. Okay. So it's a long one. Okay. Now, once you have it all in there, say File, Save As, and navigate to the directory that you're working in. Not the directory for the data, the directory for the Python file. They could be the same, but this file needs to go into the same directory as your other Python file that you're working on. So for me, it's this one. It's sec.py. And I'm going to make sure you call it sec.py. So I already have a file in there. You need to make sure you have one too. Oops, I hit cancel instead of save. So sec.py, hit save. Yeah, I want to replace it. So now you have, see, you need to make sure that so if you go to both of these files, look at the path, C courses, SPA, M8, C courses, SPA, M8. Both of these Python files, they both have the PY extension, and they're both in the exact same location, okay? That's required. Okay. Now what I want you to do is go ahead and run the sec.py one. Does everybody's run? If it didn't run, you probably didn't copy it over right. Just didn't copy and paste correctly, but.
And that's how you get us the 2.5, 2.5, 3.5, and something.
Yep, exactly. Good. So that ran for you. Now, look at what it's doing. It's running this make circle with just 2 points, a 0, 0, and 5, 5. So what it's doing is telling you that the center of the minimum circle, 0, 0, 5, 5, is 2.5, 2.5. Does that make sense? See how it's right in between those two. And the distance is basically, since there's only 2 points, it's the distance to each one of those points. It's 3.535553, whatever. Okay, which should make sense because it's 2.5 is the middle. So we've got 2.5, 2.5.
So your hypotenuse is going to be.
Yeah. Is there any nice equilateral triangle?
60-degree triangle.
No, but like sorry, so not equilateral.
3, 4, 5. 3, 4, 5.
Is there any coordinate? Is there any one that where a squared? Sorry, yeah, a squared plus a squared equals c squared. Does that exist? Where it's a neat triangle or no? Okay, but 3, 4, 5 would work.
Yeah.
So I guess I just don't know how to make a circle that would do that. But the math is working, and you can see that the 2.5 is definitely right in the middle of these two. Trust me that this hypotenuse would be right. If you got 2.5, 2.5, that's the hypotenuse. Okay. All right. So now instead, what we want to do is we want to put all of this data right here. See all this data? We want to put all of that inside of here instead of this nothing. Okay. The way that we do that is now that you've done this, you can close up this sec.py. You can close it. We don't even need it to open anymore. Okay. So what we need to do is say import sec. And what that'll do is it'll pretend like sec is inside of the existing code. However, we'll still need to put SEC at the beginning of everything. So what we can do with our big point list down here, instead of printing it, we don't want to print it anymore. It's too long and annoying. So let's say SEC dot make underscore circle and feed it the point list. What's that?
SEC is not a .py.
Oh, you need to make it a .py.
Yeah.
Yep. So sec.make circle points list. Now it's going to return a circle. So I'm just going to call that C equals. Whoops. C equals. And then now I'm going to print C. I'm going to print the circle, the smallest enclosing circle. I'm going to print that in addition to these. Right? I'll let you type that out.
You got it? Okay.
You got it? Great. Okay, so I'm going to try to run this. And remember, it's only going to do this for Port Gibson. Instead of printing all of the coordinates, what it's going to do is print, this is the center of the smallest enclosing circle, and this is the radius. I'm going to also delete this line right. Print part. We don't need that anymore. That's printing this geoprocessing array object. It's not horrible, but it's not necessary. All right. So at this point, we have everything we need to calculate that C circle. Okay. Remember what it is. It's just the area of the smallest enclosing circle well, actually, it's the area of the city divided by the area of the smallest enclosing circle.
She got a problem with hers.
What, you got an error? What does your error say real quick?
No module named SEC.
Okay, so what that means is that your SEC file is not saved in the same directory. And it could be that your SEC file doesn't have the .py extension, or it could be that you didn't save it in the same folder. It has to be the exact same folder as the Python file. So you could go here, like if I go to C courses, M8, SPA, M8, and I look at, I have an sec.py, and I have the file that I'm working on. You have the same problem?
Yeah. I imported sec.py.
Oh yeah, don't import sec.py, just import sec. But the file has to have the py extension.
Sorry. All right, there we go.
All right. So did it work? Did it work for you all on the coast?
It worked for me. I don't know what's not working for hers. It looks exactly like it should.
You still getting the same error? What error are you getting?
Oh, she's getting a piece of words.
Yeah.
It says invalid syntax for the file.
Is this in red when you try to run it?
It's in red, which kind of it's saying import SEC. It's saying invalid syntax.
I think it says it's in line 3, but for example, GHY.
That's right.
Import SEC.
So does it look like this? Does import SEC look like that?
It's exactly like that.
And it's saying,
It's a trace back to this recent call last. It says file and my file name. Is it? That's right. I think it's running the wrong.
Try saving that.
Maybe that's why it won't let me.
Come back. Open up your SEC file. You know, go to the bathroom.
if you want to send me your SEC file and the other file that you're working on, I can debug it. I just need both of those. Or you can keep working on it for a second.
It's just like,
Yeah.
choose the bathroom while we're doing something. When we're messing with the SEC file, choose the bathroom.
Oh, okay. Yeah, so if you didn't copy over the SEC file exactly, that could be a problem. But
Did y'all change anything inside the SEC file?
no, we didn't. No, to change anything. Sometimes though, people will accidentally copy, like, so if I went and I copied into the interpreter window, like, I'm not saying this is what you did, but like, let's say that.
We figured it out. When she copied it, it didn't copy the number sign before smallest enclosing circle in her SEC file at the very, very top line. I was trying to run the code where it was just words.
Oh, yeah, at the very top. Makes sense?
Yeah.
All right, cool.
Yep.
All right, so this number right here, 1970, is the area of, not the area, sorry, the radius of the smallest enclosing circle. How do we get the area of the smallest enclosing circle? Math.py times radius squared. So like that.
Yeah.
I think that the actual command is it 1 caret or 2? I think it's like that in Python. Anyway, let's see if that works.
So how does it change? We have set a variable for radius, right?
Right, radius doesn't equal anything yet. How do we actually get the radius from C? Because C contains 3 numbers.
Right. It'll be the third number, is number
Yeah.
2.
So C number 2, right? So instead of radius, we'll go C2 like that, right? And so this we'll call this circle area equals. So now instead of printing C, I'm going to print circle area. Run that guy, see if it works. Okay, so that didn't work. Maybe it's 2 carets. Yeah, that's probably when you're just trying to square something. That's probably it doesn't work. Okay. I'm getting my computer languages in my head all mixed up, so I'm just going to do what Caleb suggests, which is what I did first, if you can see. So instead of squaring it, the equivalent of squaring it is just putting it in there twice. And we know that'll work. If I was really curious, I could just go Python exponent. Oh, 2 asterisks, okay. All right, so here's the area of the smallest enclosing circle right there. Okay.
I got something.
What did you get?
122022202. Just completely different.
Sounds like binary.
The rest of the numbers are the same though.
I've got 1, 2, 2. Yeah, I got the same thing. I got 122022202. 0.9694. Yeah.
So we've got somebody up here that has the same. Did you print? What did you print? Circle area?
Yes, printing circle area.
And also C after that, but that was after this.
Oh, interesting that we're using the same.
But previously, we did what Gibson was.
All the other numbers are the same though, right?
Oh, right now, I'm looking at it.
Okay, so this is one thing we're going to do to test. One thing that we're going to do is see if the area itself is the same for Fort Gibson. See if we're working with the same circle to begin with. So I'm going to print circle area, comma, area. Let's see what happens. Oh wait, look, now all of a sudden I got a different number. Is that the number you guys got? 12891?
No, closer than that one. But I got the same area as you though. The area is exactly the same.
Okay. I'm gonna run this and see if I'm gonna get a different number every time I run it.
There it is.
That's not what we did. That's strange.
I'm gonna run it a few times. That is strange. I mean, why should it produce a different number?
That's what we've been getting.
That's what you're getting right there?
Yes.
Okay. At least we're all getting the same number now. I don't know why it took me running it 3 times to get the same number as y'all. All right, so what we want to do is take Fort Gibson's area and divide it by this area, because this number will always be larger unless it's a perfect circle. Then they should be the same. Okay. So instead of printing it, we're just gonna, instead of printing, I'm gonna say, I'm gonna call this C circle equals circle area, or I'm gonna say area divided by circle area, because that one will always be a bigger one. And then I'll print C circle down here. I'm gonna run this just to make sure we're getting the same number still. So I'm getting for Port Gibson, this is the perimeter I'm getting, and then these are the 4 parameters, and this is what I'm getting for Port Gibson. Did you change it? You sure run it? What'd you get for the last number there, Caleb?
So I've got, I got 0.26488. I have definitely different numbers.
You have different numbers, all of them?
Not written. I've got a simple area and so on. Comment else out there. I've got too many things.
On the coast, were you able to run this yet?
Yeah,
What are you?
mine is the same as yours.
You say this, fine, good. All right.
Wait, mine is slightly different than yours. Hers is slightly different than yours too. Our C's are 3.7 instead of 0.35.
Okay. I'm not sure why that is. I'm wondering if like it isn't copying over each time or something because of this break, where it's actually not updating.
Yeah.
So let's delete this delete row and break. Let's delete these 2 statements and then run it again for the entire thing again. So if I go in here and delete these 2 statements right here. Okay, I'm going to try to run the entire thing now. Now it's going to take a few more seconds to run. See how it takes a little bit longer to run?
That runs into that same error.
Oh, you guys get the same error?
Yep.
Okay, look at where it failed on Greenville. Okay, I actually remember this fail on last year too. So it fails on Greenville when we try to get a point object at some point. See, what it's trying to do is there's some part of this that doesn't have an X and a Y for some reason in Greenville. I'm not sure. Is Greenville shaped weird or anything?
It's on the river, so it may have something that's cut off from the rest of it.
But for some reason, there's some coordinate that's not going in when we try to make, that's what this means. Pointless dot append, it's not able to get core.x. It's failing at that point. If there's one point that it's not working, that's not a big deal. I don't know why it's failing. It's probably because there's some weird coordinate that either doesn't have an X and a Y. You know, it's been entered wrongly in the GIS system. It doesn't have an X or a Y, something like that. What can we do to solve this problem? Well, I mentioned earlier in the course, just briefly, a try statement. Anybody remember what try does? That's right. Exactly. So I don't know if you heard that, but it basically tells it to try something, but if it doesn't work, it will go in, it'll run this line of code here. So I'm just going to print. So there's a bad point somewhere. Is it? Am I forgetting my syntax again? Try. Just making sure. I'm surprised that catch doesn't show up. Except, sorry, in pretty sure that's JavaScript that I was doing. So it's try except. So I'm going to try to run this line of code. If it runs, great, it'll keep going. If not, if it has a problem with this line of code, it will just print out the word bad point. Okay? And it'll keep going with the program. That's what's great about it. Okay? Now, I believe I mentioned this when I brought this point up earlier. The bad thing about putting try except statements everywhere in your code is that it won't tell you the nature of your error. It'll just do bad point instead of telling you the error. So only do it if you know that it's okay if it skips it. And it's okay, because what's this line doing right here? It's finding the coordinate and it's putting it into a list. If we don't get one point into a list, it's not a national emergency. It's probably not very likely that that point is one that would determine the minimum bounding circle. And even if it did, for a whole city, a single point, even if it was on the corner, it's still going to get the 2 points that were closest to the corner. So
It still breaks at Greenville.
Still breaks at Greenville. Let's see what it says.
It says ERR isn't defined.
Oh, okay. Let me look at the syntax. Okay. Sorry, that's also, I guess that's also JavaScript. JavaScript allows you to, basically, the message that it printed off, the stuff in the red text, in JavaScript, it will return that into the ERR variable, so you can print that ERR variable, whereas in Python, it doesn't look like it does that. So we just have to leave that out.
First one all the way through.
Mine stopped at Winstonville.
All right, so mine stops at Gunnison. Where does yours stop?
Winstonville.
Mine stopped at French Camp.
Did everybody get the same error here?
None type.
None type object has no attribute get item.
Mine's a little longer.
Hers is longer, but I do have none type on. Mine's the same as yours, except mine's at.
What's yours say?
I got a unsupported operand type for one people in my line 19, which is not.
Okay, so
Hadn't been an issue with it.
the error that's happening right now is that it's returning a circle that just isn't big enough. It's like not even correct. Where are you?
So it's saying right here that something's wrong here with operand type. There's a conflict between the import and it's running. It doesn't have the
Maybe
point.
like
Well, I have to have that.
no, but maybe like it's just now it's being used because it's still open. It's just changed this to. Oh, I don't know how this got back in here. See that?
Yeah.
That's the problem right there. I don't know how it got back in there. Maybe
press undo or something. But that's the problem, because that was a tuple. I mean, anytime there's a comma in there.
The original one.
See,
They can probably understand this in that city.
there you go. So you got a bad point. Oh, are you still printing all the coordinates?
Yeah.
Okay, so it's gonna take like 4 hours to run if you don't have the, like literally forever. All right, so my error here is because for this city, and you might have hit it on a different city, it didn't create a circle with any area.
Like it didn't return anything from the function. So there's no C2. C is empty. Maybe I should print C just to show that. Print C. So now I'm going to run it, and hopefully it'll fail in the same spot. So usually C is a tuple that represents the center point. So it failed in a different spot, Brooksville. Okay, so every once in a while it's just failing on that point. Okay. All right, so this happened last year, and I don't know exactly why it's happening, other than that formula isn't working quite right. So the way we solved this last year was to say BUF equals row 1 dot buffer, and then said 0.00000001, and then change this to buff.
How many zeros is that?
I just typed in a bunch. It doesn't really matter how many zeros. Okay, we initially solved this last year by just ignoring that error. Okay, so last year we just still have the error. Maybe I'm just going to do 2. If this doesn't work, we can just ignore the error this year too. Okay.
A bunch of bad points.
Yeah, there are a fair number of bad points, and that's okay, because like I said, the probability of one particular point mattering in a city is really, really low. So when you get a bad point, it's okay, even if there's 1 or 2 in every city. Right. Yeah. So you get some bad points, but it works now. The buffer is 0.1, and so we're buffering every city by how much? Remember, that's in meters. So what's 0.1? Exactly. Buffering every city by a centimeter. It's hundredths of a, yeah. So really, in terms of the effect on the area, that's nothing. Okay. Let's see if we went out to a millimeter, if it would still run for the whole thing. But sometimes when people digitize, or sometimes when cities, I'm sorry, not just cities, sometimes when any shape is created in ArcGIS, the shape that's created is not, it doesn't go into the file exactly right, okay? Or exactly how every other program that's written to operate on it expects it. So it doesn't like a millimeter, so it has to be a centimeter. So centimeter works, And anyway, so we're buffering it. We're accepting that little teeny bit of an error associated with that. So now we'll go through, what's the name of the city that's almost a perfect circle? Woodland. So still, that should have a value around 1. All right. I'm gonna have a hard time finding Woodland, I think. Look at Pelahatchie though. Look at the value for this thing that we just created, 0.0916. So what that means is that the area of Pelahatchie is only 9% of the area of the smallest circle that would fit around Pelahatchie. Remember from last week, Pelahatchie was the long one that had the little spider legs that went out onto I-20. I think that's the least compact city.
Dr. Avery,
Yeah.
Close out that instance and run a fresh one, you can just search and find Woodland. But if you
Oh yeah, that's good advice.
96.
Great advice. Thank you. I did just find Woodland, so.
And part of that's probably digitizing, because I know some digitizing some of the circle edge kind of a little.
Right. And plus, if that circle was defined in a different coordinate system, in other words, like it was defined in Mississippi State Plane East, which it might have been, then the circle will be different. When you project that circle into MSTM, which is what we're dealing with, the circle will be slightly different. All right. All right, so this runs, this works. I'm gonna clean up a little bit. I'm gonna delete this print C. Okay, just to further explain what's happening here is we're buffering this circle, we're buffering the city just by 1 centimeter. And what that does a lot is just, it heals the shape. It turns the shape into the shape that ArcGIS expects. And this actually isn't unique to this problem. So if you ever do get into a position where you're programming, for your job later down the road, think about this. Sometimes if a particular thing fails, it doesn't produce the expected result, you try buffering the circle by a very small amount. And it just kind of fixes, it forces it to rewrite that geometry out into the way that it expects it to be. There is a, PostGIS actually has a very similar problem. PostGIS is another GIS system that runs inside of a database. Same exact thing. You lots of times just create it as a new polygon, and it runs better just by buffering it. Okay, let's look back at the requirements for the lab. I'm losing my voice today, I don't know why. Okay, so we've calculated all 4 of these. That's all we're going to calculate, all right? But you need to modify your program because it needs to take an input shapefile. Then it adds, so right now we copy this over. That's fine, but we need to add, I'll put a comment here, add 4 new fields to FC2. Okay, how do we do that? Well, we can run at, why couldn't I add 4 new fields to FC2 right now at this point in the code?
You don't have the columns yet. You don't know where to set them or what to
Does FC2 even exist at this point in the code?
Oh, no.
No. So we need to put this under here. So we need to add 4 new fields. I don't really care what you call them, but they need to hold para, shape, circle, and S circle. So you can call them that. Okay. we've done that before. Let's see if I can find an example from an earlier week. I'm going to go back to week 6. Okay, week 6, we added fields right here. In fact, we want to add a double field. So I'm going to take this 1, 2, 3, 4, do something like that. You got to change some things. Okay, you got to change this. Well, that's going to stay a double. But this is the field name. Here, I'll make this general. So this is where you're going to add. This is the table, and this is field name. Okay, and I'll delete. I'm going to comment this out too. So you're gonna add 4 fields. All right. Now, how are we going to make sure that those 4 new fields that we just added are in our cursor? What do we need to do that? How do we change this? How do we change? So what do we need to change? See this field that I have highlighted, or this row that I have highlighted? This is a list of fields that we want to include in our cursor. That's what this is. This right here, this line. So right now we have the name, but we also want, I'll just put a comment here. Add the other fields that you just created. So you want to add, how do we make this list longer? What needs to go? What's that?
Just add the list.
Yeah, we can just, like this, except for you don't want to type in this. You want to type in the names of these fields that you just added, okay? All right, so that's what you need to do. And then finally, you need to update those new fields. So let's call this first field, let's just say we call it para, okay? That's the name of the new field. How do we reference that field down here? Will it be row 1, row 2? What would it be?
Row 2.
Right, exactly. So somewhere down here, you need to say row 2 equals, and then this is going to be the P2A. Okay. I'm going to comment that out for now. Okay. So now you're updating not only the shape, but you're also updating the P to A. And you need to do this 4 times, or 3 more times, or total. Because you need to store in P3 shape index, P4 S circle, and P5 C circle. But you need to make sure they're here. You need to make sure you create them, and you need to make sure that you put the values in the row. All right. So I'm going to delete this right here too. Just so that this will still run, but you need to do what I've commented out. Okay. One final thing that I want to show you, okay, is what I want to do is, instead of showing the difference between the buffer and the original, I want to show the difference between the largest, the circle, the smallest enclosing circle, and the polygon buffer. Does that make sense? So basically, I'm going to open up our catalog. I got to close it again though. I'm just gonna show you what I mean here. Okay, so I'm gonna go to the raw cities, not the cities. So these are raw cities, and let's zoom into Long Beach again. Okay, so the smallest inscribing circle is probably going to look like this, right? What I want to do is take the difference of that smallest circle and the original shape. Right now, I've buffered this shape. I'm going to take that out. So that's this one right here. So instead of buffering the original polygon, I want to buffer a new point. Okay. So let's go back to the help. So this is for polygon. Let's go to point geometry. Oh, wait, let's go to polygon. How do we get the center? No, it's not the center that we want. We need to create a new point geometry. How do we create one of these things? Hold on. You all aren't going anywhere. That was an intermediate step, just calculating the shape index. Yeah, that's it. This is where we were saying did not work before last year. Okay. Okay, this is how you create a new point geometry. Okay. All right, so what I'm going to do here is I'm going to create a new point geometry that is the C. So it's going to be at a new point at the center, and then I'm going to buffer that CP CP by C3 or C2, which is the third one. So I've created a new point geometry at the center of that new circle that got created. I'll close down our catalog here. And now the new geometry in this city copy will be the area that is outside of that difference. Oops. I gotta have this go like, oh. Huh. So I'm getting an error. CP. It failed right on Port Gibson. Buffer. It's the exact same syntax. CP2 or C2, that's this one. X, Y, bam, difference. All right, well, if this doesn't work, then it's fine. I just wanted to actually show you the difference between those two. I'm not sure why this is failing. Okay, so what we're going to do now is just show you the circles. So I'm storing the circles, the minimum bounding circles, instead of the difference between the minimum bounding circles. So we'll show that, because that'll be almost as cool. Okay, so open up ArcMap. So these are all the minimum bounding circles. So if I zoom in here to Long Beach again, this is probably Long Beach. So that's Long Beach. And if I toggle back between, well, it won't, if I did this in ArcMap, I toggle between these two, you can see how those circles are the minimum bounding circles. See that? Like it's pretty apparent. What's this city? Probably Vicksburg. You can see Vicksburg get bigger and smaller. Yeah.
Let's see how big Hasbrook is.
Arc. Let's do this in ArcMap. What I was trying to do is actually make the result the difference between the two, so you'd actually see the cutout. I don't know why that was failing. I'll try to get that working later, but that's not part of what you need to do anyway. C temp. I'm going to add these two in here. So now if we zoom down into Hattiesburg, so this is Petal, it's not Hattiesburg. So this is the smallest circle that will fit around Hattiesburg right there. And see, this is the smallest circle that will fit around Purvis. See what I'm saying? And here is the smallest circle that'll fit around, what is city? Summerall? Summerall. Columbia, and so on. Okay. So where is Wood whatever?
Up in the northeast, kind of close to Newport.
This is the smallest circle that fit around Pelahatchie. So it's a pretty big circle. Up in the northwest?
Down on the bottom left, down right, yeah, right in there.
Right there, look.
Yeah.
There we go. So you can see that this circle in green is probably supposed to be a true circle, but there's been either digitizing error or something, that circle, or projection error like I talked about before, but that one is really, really close. So if we hit the information button, we can see how its statistics. Let's do all layers. So here are the statistics that we get. Or sorry, no, yeah. Oh, I haven't written those attributes out. That's to do. All right. So I'm gonna close this. So this works, and the only thing that you need to do is modify it. You need to change you need to add 4 fields. You need to add 4 names of 4 fields here, and you need to update those fields 4 times right here. And then you'll be done, okay? So 1, 2, 3. So there's 4 lines of code to add here, 4 lines of code to add here. I've already started each of those for you. So 3 more lines of code to add, 1 to modify a bit, and then you need to add 4 things to this list. It should be good. Should be good to go at that point. So that's what you need to finish up. All right, any questions? And it's like air conditioner really kicked in up here. All right, I'll just leave that up for a few minutes. Caleb's got a question on last or 2 weeks ago.
You got a name? I think the strings are
Sure. We're going to check this for the 2 weeks. Okay, so the
The script ran on mine.
okay, good.
This is the part where you're messing up. So your output layer is the bug layer stuff. Okay. You don't really need that. What you need is 2 fields.
What's the knife cuts on?
So bring the script up real quick.
Okay.
We're talking. All right, so see pod field and the HU field, simple work. Okay. All right. So yeah. So right now we have 0, 1, 2, 3. So we need
Yeah.
Perhaps on the field or something.
No, you got the right amount of fields over here. Okay, so right now 0 is in features population.
All right.
In overlay is your overlay layer. Okay. Oh, pop field. That's the one you don't have. So go down here, change buffer intersections. That's one we don't need. Just call it pop field. Field's fine. And then dropped it. But it also needs to be changed to field.
That's what.
And then you need to say obtain from population. Now we're getting there. Go back over here. So now you have pop field, you have in overlay,
Which is overlay layer.
right? And then your output layer, which is fine. Okay. Now I think what I would prefer is if you copy this up and put it above.
This.
Yeah, just take the whole line.
3.
Yeah. Collapse. And then press enter. Now just put 3 up there and 4 down there. Actually, there's nothing really magical about this going 0, 1, 2, 3, 4. We could have just changed those numbers, but so now we have our huck field. So go down here and create a new one. Just call it overlay field or open field or whatever. And then drop down.
That's a field.
It's a field again.
Yeah.
Exactly. Now move that up.
That's going to be obtained from
Overlay. Awesome. Now move that up. So go here.
This goes up.
This goes up. Up. Yeah. So now we can just make sure we get it right. We got population. Field. Overlay layer. Overlay field.
All the output is the other output. Oh, okay, all right. That's what I was trying to reconcile in my brain, and it was not there.
So say, okay, now let's try running it, because I think it'll run it. Because it was,
Right from here.
you double click. So if you choose the population layer, which is C whatever. You just have to. Sorry. Why? No. That's this.
Oh, that's not.
Oh, that's it. Yep. C tracks.
C-tracks.
Okay. And then you drop down, you choose the population field, which is that P001,
Yeah.
whatever. Overlay layer.
Overlay.
Marsh.
Marsh.
Those other ones don't exist, but those are like.
Field in that one. Okay.
Yep. All right, I was going to save it right there. That's fine. So say okay. It should run. Yeah. I ran it on my computer just fine after I did what you did. Okay. Good. So go.
Line 13.
Be done with it. In features, it's not defined. Go back to your code for a second.
Line 13. 11, 12, 13, right here. Dark by and so then it's an in features area double. In features right there, not defined.
That's which line is that?
It says right here.
Add field. And in features are the same. File. Oh.
Is it an underscore for management? Features.
I'm sorry.
What? Oh, it's not really simple.
It probably is.
Excuse me. I didn't know you didn't work. Oh.
That's it. Let me see. It's spelled the exact same way, right? Let me see if this is, because the only other thing that's different about your code is that I hard coded those in. That's exactly the same, right?
Yeah. Jesus, we're on a curve, right?
Something like that. Yeah, but it's failing because in feature doesn't exist. Be like, what if we went like this? If I copied this up here, I went like this, like that. Now it should fail the second time when it meets pot heel.
Where's that? Down here somewhere?
Oh, why is it? Same deal. Okay, so what, do we spell something wrong? I copied and pasted that there. Okay. Is this the same as this? Doesn't look the same. So where is this?
It should be the same folder.
This is this location.
Okay, there it is, folder.
So let's go to add.
As long as it's with double.
5, 6, Caleb Smith, 6 plus
Oh, that five, that's it.
I'm not saying it's going to solve the problem, but
But it was looking wrong.
it was running a different script.
It was probably already running my original script before I fixed it the other day.
So, yeah, it looks like it's running.
All right, hey, it is, it's interesting.
So, yeah, so the two things that were wrong was we didn't have lined up in each of the fields. The toolbox and the script didn't match.
Yeah.
The other problem was we were running an old script.
Right.
Now it works. Everything's awesome. Like a movie.
Everything is awesome. Oh, yeah. My son right now is all into Lego Batman and Lego, he loves Lego Batman and Lego Hulk. He is all about Lego Hulk. There's a Marvel deal with someone on Netflix that he wants to watch. So that's
So, Bryce and Kristen, do you have any questions right now at this point?
So we're trying to add in the rest of the field, we already have the order, right, the para?
Yes, well, I didn't actually, I commented that all back out, but yeah, like you could put, you're saying you already have this, like that. And then I could add this field in, I could say para. What would I put here for table? Which table do I want to add this para field into?
The city and copy.
Right, which is, right now it has a variable SC2 attached to it, so I might as well use the variable. You see what I did there? This, okay? And it's fine if it's a double. So we have para down here. Now, if we want to actually save that out, we do this, okay? So now at this point, if I run this, I don't know if that's where y'all are, but I've added it in those 3 locations. Now when I run this, I'll open up our catalog when this finishes, and I'll have a new field called para. I just didn't want to run that before. Okay, so now in this copy, if I go to table, I have a new field called para. See that right way over on the side?
So your goal here is to add 3 more fields. And then instead of putting para, put the other 3, metrics.
Real quick.
Yeah, sure.
I'm going to also okay. So now that's this code here, this 2016 example 2.py is up online as well. But I'll leave this up. If you haven't, I don't know if I pointed you on the path to answering a question, or you still have another question, just let me know.
Can you go to the top of your code real quick?
Sure. Should probably make this a 3 more now.
How many, so we're gonna have to add in 4 new fields.
4 new fields total, yeah.
So we need to do the add field management for each one?
That's correct. You do that 4 times, and then you need to add each one of those to the fields list over here. Okay? And then you need to actually put the code down here. So they're going to be this one, this one, this one, and this one. Those are the values that are going to go into there.
Okay.
Cool.
Do we have to create a different FC field for each one, Dr. Raver?
What do you mean by FC field?
We have FC equals, and we have FC2 equals, but would we have to make any more than that? Is that it?
So what, I think I understand your question. I'm going to ask you, are you adding these fields into 4 different feature classes, or are you adding them into a single feature class? From what I've described.
Not even a single feature class.
Right, exactly. You're adding them all into the same feature class. Maybe that's what you were asking me, like, so anyway, you are adding them all into the same feature class. So does that help answer your question?
I think so.
This is the feature class you're adding it into. So you're adding them all into FC2. Does that answer your question more explicitly?
Yes, it's good.
Yeah, okay.
Now, you scroll down, just a moment there, I'm trying to figure out, para is just a label you created for the thing, but there's nothing in your code that's actually called para.
You're right, yeah, so this should be called para, but they're both variables, and so as long as you name them the right
Something
thing.
equal them out
Yeah.
each other somewhere in my.
So the variable PTOA, its value is going into the para field.
Right.
Yeah.
Okay, that's what I was trying to figure. Okay, I got it. Good, that's what, all right, I gotta get home for my son's sleep.
All right. Yeah, you're pretty close on this one.
Yeah. I don't have much more to do.
All right, so I'll mention this next week, but the last assignment will be for this one will be to just turn this into a toolbox. So the toolbox will take the name of a polygon shapefile, that's it. And that's all it'll take, and then the name of the output file. And then it'll calculate. So you could calculate you can calculate these metrics for any polygon shapefile in the world. What that's going to be. All right. I'm going to go ahead and close it down then. Yeah, you're welcome to take off there. I'm just going to finish off a few things. So I'll be here for a few more seconds.
Hold on, next week.